All right, so we're going to talk about car loans. So car loans are forms of annuities because you're going to make reoccurring payments um, over the life of a loan to finance a car. So first thing we're going to talk about is most dealerships will require you to make a down payment. And a down payment on the car is going to be a percent or percentage of the total cost of the car. So they'll say you have to put down 10% or 15%. So that means you're going to put down a flat amount of money first. That's subtracted from the value of the car. And then you finance the remaining money on the car. Another thing that goes into car loans is if you have a car already that you want to trade in, there's a trade in. So there are a lot of different ways to figure out your trade in. One of the ways is you can use Kelley Blue Book, and that will tell you the value of your car. So the value of the car that you own already, that you're trading in, would be based off of the mileage, the condition, and the number or the age of the car. So your trade-in will be a value that they'll give to your car that you already own. You give them your car, and then they take a certain amount of money off the top of the loan of the car. So considering this is a form of annuity, we have a formula that actually looks very similar to the formula that we used when we were talking about the retirement annuities. All right, so let's define these. The structure is a little different. Okay, so first off, you have A of P. So A of P is the amount of the loan. Then your R is your recurring payment. So that would be your monthly payment to finance the car. And then you have your N, which is the same as the N. And the other question is the number of total payments. And then your I is the same also. Your I is your interest rate. So this is the interest rate on the loan. And N is the total number of payments. So if you have a car that you're financing over 5 years, say, you would have monthly payments. So you would have 60 total payments that would represent your N. Okay, so let's look at an example. Let's look at page 36. If you don't have that, I'll bring it closer so you can see it. So let's pretend you want to buy this Honda Pilot. I have a Honda Pilot, but not that model. And it costs $38,485. So they're telling you that your down payment is 15% of the cost of the car. All right, so this tells you that right off the bat, if the car is $38,480, your down payment is 15%. So to take 15% of this, we change 15% into a decimal. So scoop it twice. And we multiply it by 0.15. Okay, so that means that your down payment is going to be $5,722. This is your down payment. So this is what you have to pay right up front. Up front, you pay $5,772. So then you're going to finance the rest because not many people have $38,000 just lying around in your account. So we're going to take $38,000 and we're going to subtract the $5,772 to find out what we're financing. So you're going to be financing $32,708. That's the amount of money that you're going to be paying in the loan. All right, so let's look at another question. Let's look at page 39. So number one says, a college student wants to buy a car and can afford to pay $200 per month. If she plans to take out a loan of 6% interest per year, with a recurring payment of $200 per month for 4 years, what price car can she buy? So this is a good thing to think about. What can you afford per month, and what kind of car, or what's your price range for the type of car that you can actually purchase? So let's look at this question. Let's see what this student can afford. Okay, so we have this formula. It looks a little different from the retirement annuity formula, because we are going to find out what she can afford, figuring that she can only afford to pay $200 per month as a recurring payment. So the best interest that she can get was 6% per year. So let's write down what we have. So we know that she can afford $200 a month. She plans to take out a car loan at 6%. That you really can't choose. 6% per year with a recurring payment of $200 per month for 4 years. What is the price that she can buy? So she's paying monthly, which means she's paying 12 times a year for 4 years. So she's going to make a total of 48 payments. Okay, so now as we begin to start entering this information, we have to be careful, because she plans to take out a loan. It's 6% per year. Now that is not per month, and her payments are made monthly. So this is monthly. This is 48 months. This is $200 a month. So you have to be careful, because this is not per month. So to get per month, we have to divide this by 12. That gets us 0.5%. That's the percentage per month. All these have to match. The monthly, this is monthly, this is monthly. If they don't match, then you have to make it so that they match. All right, now this is 0.5% per month, but that is not a decimal. That's still a percent. So we have to scoop this twice. So plugging into the formula, we're putting 0.005. Okay, so I'm going to put in my $200, which is my recurring payment. I'm putting in my interest, which is 1 plus 0.005 raised to the negative. It's part of the formula. 48 over 0.005. All right, so now we type into our calculator exactly how we see it. We have 200, and then I use the alpha y equals option. 1 minus 1 plus 0.005 raised to the negative 48 over 0.005. I press enter, and we find out that this student can afford a car with that interest rate with $200 a month for $8,516.06. So she should start looking for a car that is equal to or less than that value.